This video is for section 7.3 Trig substitution. We are often confronted with the situation where we have a constant squared minus a variable squared underneath the square root where the a is bigger than 0. Or we have the situation where the variable is first squared minus the constant squared, all under the square root, again, where a is bigger than 0. Or finally, we have the situation where it doesn't matter which order the constant or variable appear, because we use addition underneath the square root. These three situations, when trying to find the antiderivative, can pose a challenge. And so we have some techniques that we can use to make those situations simpler. The first thing I want to point out is something that's very important. It is tempting often to say, well, a squared minus x squared underneath the square root simplifies to just a minus x. And the reason we do that, I think, is because we accidentally say, well, I have a square root symbol and I have squared symbols, so somehow those simplify. But that's incorrect because these are being subtracted, and that's also true with the case of being added. So this is wrong. Don't do this. The correct way to think about this is to use something called an inverse substitution. And what we're going to do with an inverse substitution is take our variable x and make it equal to some other function, but usually in terms of theta. So a way to write this would be x is equal to a function of theta. Now remember that an inverse function has to be a function that is 1 to 1. So our function f of theta must be 1 to 1. Let me show you an example of how this could work. So I'm going to use the situation where I have the constant first minus the variable underneath the square root. So I'm going to make this substitution of x being equal to a constant times the sine of theta. So then a squared minus the variable x squared underneath the square root is the same thing as a squared minus a times sine of theta, the whole thing squared, all underneath the square root, which then becomes a squared minus a squared times sine squared of theta underneath the square root. Then I can factor out a squared in both terms, and I get a squared times the quantity 1 minus sine squared of theta, all underneath the square root. So now what I'm going to do is employ the Pythagoras' identity, and 1 minus sine squared of theta is the same thing as the cosine squared of theta. And that's underneath the square root. So now I have two terms being multiplied underneath the square root, and I'm allowed to simplify. So I have a times the cosine of theta. Now we have to be careful here, because we were told originally that we have the situation where a is positive. A is positive. But cosine can be both positive and negative. And we squared cosine in this step above. So then we have to make sure that we add an absolute value symbol to that simplification. So then the idea becomes that we have taken this antiderivative and through some transformation made a new antiderivative that is now a function of theta instead of being a function of x. And that technique is a very powerful and useful idea.